Random variable. Let us define what is a random variable. A function which can take on any value from the sample space and its range is some set of real numbers is called random variable. Random variables are classified as discrete random variable and continuous random variable. Discrete random variables are those which can take on only finite number of values, while the continuous random variables are those which can take on infinite number of values. Now let us define the cumulative distribution function. So the cumulative distribution function is mathematically expressed as fx of x equals to the probability of the random variable x less than equals to the event x. Then the properties of cumulative distribution function. The first property, that is the f of x lies between 0 and 1, that means the CDF is always bounded between 0 and 1. The second property, for no possible event, that is the CDF of minus infinite is always equals to 1, and the probability of all possible events, that is the CDF of infinite is equals to 1. The third property, if the event x1 is less than equals to the event x2, then the CDF of x1 is less than equals to the CDF of x2, that means the CDF is a non-decreasing function. Property number 4, again if the event x1 is less than equals to x2, then the probability of the random variable lies between the x1 and x2 is equals to the difference between the CDF of x2 and the CDF of x1. Now how to express the random variable, discrete random variable. So the CDF of discrete random variable expressed as fx of x equals to 0 for x lies between minus infinity to x1, and for x lies between x1 to xn, it is given by summation from j equals to 1 to n, the probability of the random variable x equals to the event x, and for x lies between xn to infinite, the CDF is equals to 1. Then let us define the probability density function. The probability density function, or PDF, is the derivative of the CDF, and mathematically it is expressed as small f x of x equals to the derivative of CDF fx of x. The properties of CDFs are: property number 1, the PDF is always greater than equals to 0 for all values of x, that means the PDF is always non-zero. The second property is the area under PDF is always equals to 1, and this can be obtained by taking the integration of the PDF over the interval minus infinity to infinity and equating this thing to 1. The third property, we can obtain the CDF by integrating the PDF over the interval minus infinity to x. So here the CDF fx of x equals to integrating the PDF from minus infinity to x. The fourth property, the probability of the random variable x between the event x1 and x2 can be obtained by integrating the PDF over the interval x1 to x2, that is the area under the PDF. Now let us take the examples based on the CDF and PDF. Example number 1, the function shown in figure represents a PDF, then what is the value of a? See here, the figure is given which consists of one rectangle and a triangle, and you know The property of the PDF, that is the area under the PDF, is always equals to 1. So integrating this PDF over the interval from minus infinity to infinity, that is equals to 1. So first here we will find out the area of rectangle, then the area of triangle, and then the total area of this figure. So here the area of rectangle is equals to 6 into A, that is equals to 6A, and the area of triangle is equals to half into 2 into 3A minus A, which is the height, and that is equals to twice A. So the total area is equals to the area of rectangle plus area of triangle, and that is equals to 8A, and equating this thing to 1. So from this we can get the value of A, which is equals to 1 by 8 in this case. Consider the second problem. If a given PDF is of the form P of x equals to k into e to the power minus alpha mod x, where x lies between minus infinity to infinity, then the value of k is. Here we have to find out the value of k. Again, using the property of the PDF, that is the area under the PDF is equals to 1. Here the PDF is k into e to the power minus alpha into mod x. So we will divide this integration for the positive values of x and negative values of x. So for the positive values of x, we will integrate this PDF from 0 to infinite, and for negative values of x, we will integrate this PDF from minus infinity to 0. So here PDF, that is k into e to the power alpha x into dx, integrating over the interval minus infinity to 0, plus the PDF integrating over 0 to infinite, that is k into e to the power minus alpha x for the positive value dx equals to 1. And then simplifying this integrations, finally you will get k by alpha plus k by alpha equals to twice k by alpha, that is equals to 1. So from this we can find out the value of k, which is equals to alpha by 2. Consider the next problem. If the PDF px of x equals to m into e to the power minus 2 mod x plus n into e to the power minus 3 mod x is the valid PDF for real random variable x when both m and n are real positive numbers. The equations relating to m and n is, 4 options are given. The option number 1, A is m plus 2 by 3 n equals to 1. Option B is 2m plus n by 3 equals to 1. Option 3 is m plus n equals to 1. And option D is m plus n equals to 3. Again, the area under the PDF is equals to 1, that is integrating this PDF over the interval minus infinity to infinity equals to 1. Now for the first part, that is the m into e to the power minus 2 mod x, again we will integrate this first term for the positive values of x and for the negative values of x. And for the second term, that is n into e to the power minus 3 mod x, we will also again integrate this n term for the positive values of x and for the negative values of x. So for the first term, that is the m into e to the power minus 2 mod x, integrating from for negative values of x, that is integrating from minus infinity to 0 into m e to the power twice x dx, plus now for the negative, for positive values of x, integrating from 0 to infinite m into e to the power minus 2x dx, plus similarly for the n term, integrating for positive values of x and the negative values of x, and equating this thing equals to 1. And then simplifying this integration, we will get m into 1 by 2 plus m into 1 by 2 plus n into 1 by 3 plus n into 1 by 3 equals to 1. And simplifying this thing, finally we will get m plus 2 by 3 n equals to 1. Therefore, option A is correct. Next problem. If a given PDF fx of x equals to a into e to the power minus b mod x, where a and b are constants, then calculate number 1 relation between a and b, number 2 CDF of x. Again, the area under the PDF is equals to 1. So, integrating this PDF over the interval minus infinity to infinity for the positive value of x and for the negative values of x. Therefore, for negative values of x, integrating this PDF from minus infinity to the 0, it will be a into e to the power bx dx. Then integrating this PDF for positive value of x over the interval 0 to infinite, and that is equals to 1. So, simplifying this integration, we will get a by b plus a by b, that is equals to twice a by b and equals to 1. Therefore, b equals to twice a. So, this is the required relation between the constants a and b. For the second part, to find out the CDF, again we will integrate this PDF for the positive values of x and for the negative values of x. So, for x greater than 0, the CDF is equals to the integration of PDF over the interval minus infinity to x. So, this is equals to integrating the PDF from minus infinity to 0 plus integrating the PDF from 0 to x for positive and negative values of x. And simplifying this integration, here we will get twice a by b minus a by b into e to the power minus bx. Then putting the value of b, that is equals to twice a, into this equation, we will get twice a by twice a minus a by twice a e to the power minus bx. So, finally, for x greater than 0, the CDF is 1 minus 1 by 2 e to the power minus bx. Again, obtain the CDF for the x less than 0, that is for the negative values of x. So, integrating the given PDF from minus infinity to x. Therefore, the CDF fx of x equals to integrating from minus infinity to x a into e to the power bx dx, and simplifying this thing, we will get a by b into e to the power bx, and putting the value of b here, we will get a by twice a e to the power bx, and that is equals to 1 by 2 e to the power bx. So, finally, the CDF is equals to 1 by 2 e to the power bx for x less than 0 and 1 minus 1 by 2 e to the power minus bx for x greater than 0. Now, let us define what is joint PDF, joint CDF, relationship between the joint PDF, probability and marginal densities, conditional PDFs, etc. So, the joint PDF for two random variables x and y is expressed as fxy of xy equals to the probability of the event x less than equals to the random variable x and the probability of event y less than equals to y. The properties of joint CDF are: number 1, the joint PDF is always greater than equals to 0, that means it is a non-negative. Second property is the joint PDF is a non-decreasing function. Now then, let us define joint PDF. So here the joint PDF of two random variables x and y is obtained by taking the derivative of the joint CDI, and it is expressed as fxy of xy equals to d2 fxy of xy by dxy by dx into dy. Properties of joint PDF are: the property number 1, the joint PDF of two random variables x and y is always greater than equals to 0, that means it's a non-negative. Property number 2, the total area of joint PDF is unity, and this is obtained by integrating the joint PDF over the interval minus infinity to infinity and equating this thing to equals to 1. Relationship between joint PDF and probability. We know that the probability of random variable lies between x1 and x2 is obtained by integrating the PDF over the interval x1 to x2. So for two random variables x and y, we can obtain the probability of the random variable x between x1 and x2 and the random variable y between y1 and y2 equals to integrating the joint PDF over the interval from minus y1 to y2 and x1 to x2. For statistically independent random variables, we can obtain the joint PDF fxy xy equals to the PDF of the random variable x, that is fx into x, into the PDF of random variable y fy of y, which are also called as a marginal densities. Now next is the marginal densities. How to find out the PDF for single random variable obtained from joint PDF. So we can obtain the PDF for a single random variable x by integrating the joint PDF over the interval minus infinity to infinity. So here for random variable x, fx of x equals to integrating the joint PDF over the interval minus infinity to infinity, and the PDF of the second random variable, that is y, can be obtained by integrating the joint PDF over the interval minus infinity to infinity, and these are called as a marginal densities. Then the conditional PDF. Conditional PDF of random variable y, given that the random variable x equals to the event x, is obtained by this expression fy of y by x equals to the joint PDF of xy, that is fxy xy, divided by the marginal density of x, that is fx of x. Similarly, the conditional PDF of x, given that the random variable y equals to the event y, is obtained by fx of x by y equals to the joint PDF fxy of xy by marginal density of y. Then the properties of the conditional PDFs. The property number 1, the conditional PDFs are always non-negative, that is fx of x by y is greater than equals to 0 and fy of y by x is greater than equals to 0. Property number 2 represents that the area under the conditional PDF is always unity. Property number 3, if x and y are statistically independent random variables, then the conditional PDF reduces to marginal density. So from the property number 3, we can obtain the conditional PDF equals to the marginal density for statistically independent random variables. Now let us define the statistical averages of random variables. The first, how to find out the mean or the average of the random variable. So mean or average of random variable is denoted by mx or expected value of x or x bar, and this is obtained by multiplying the PDF by x and taking this multiplying this PDF by x and integrating over the interval from minus infinity to infinity for continuous random variable. Similarly, for discrete random variable, the mean or average is given by mx equals to expected value of x equals to x bar equals to summation from I equals to 1 to n xi into pxi. This is for discrete random variable. Now, if function g of x transforms the random variable x into another random variable, then the mean value is given by m equals to jx bar equals to the expected value of g of x equals to, here just replace x by g of x, therefore, and multiply it with this PDF and integrate over from the interval minus infinity to infinity. Then let us define the term moment and variance. For any random variable, the expected value of x to the power n equals to x to the power n bar is obtained by multiplying the PDF with the x to the power n and integrating this thing over the interval minus infinity to infinity, which is called as the nth moment of any random variable. Now, if n equals to 1, then this expected value of x equals to x bar, and that is equals to mean value, which is for first moment. For the second moment, if n equals to 2, then expected value of x square equals to x bar square is obtained by integrating from minus infinity to infinity x square into the PDF fx of x dx, which is called as the second moment, also called as mean square value. Then the central moment, which is the moment of difference between the random variable x and mean. So the expected value of x minus x bar power n is obtained by integrating over the interval minus infinity to infinity x minus x bar power n into PDF fx of x into dx. Now, if n equals to 0 here, then expected value of 1 is equals to 1, which is the area under the PDF. And if n equals to 1, the expected value of x minus x bar equals to integrating minus infinity to infinity x minus x bar and PDF dx, and simplifying this, you will get the mean value of x minus mean value of x, and that is equals to 0. Therefore, the value of first order central moment is always 0. The second order central moment about mean is obtained by putting n equals to 2. So here the expected value of x minus x bar square is equals to integrating over the interval minus infinity to infinity x minus x bar square into PDF. So this is this gives the variance. So here the simplifying this, you will get the variance, which is represented here by sigma x square equals to the expected value of x square minus x bar square. So the variance is equals to the difference between the mean square value and the square of the mean. We can obtain the standard deviation from the variance by taking the root of the variance. Now let us take the example based on this mean variance. Example number 1. Suppose a random variable x takes the values minus 3, minus 1, 2, 5 with respective probabilities 2k minus 3 by 10, k minus 2 by 10, k minus 1 by 10, k plus 1 by 10, Calculate expected value of random variable x. So total probability must be equals to 1 using this. Now we can add these given probabilities and equate this thing equals to 1 and to find the value of k here. So 2k minus 3 by 10 plus k minus 2 by 10 plus k minus 1 by 10 plus k plus 1 by 10 equals to 1. From this we can find out the value of the k, that is equals to 3. And we can find from this we can find out the probabilities for the events minus 3, minus 1, 2 and 5. Therefore, for minus 3 just put k equals to 3 in 2k minus 3 by 10. So here you will get 3 by 10. Similarly, you can find out the probability of the events for the minus 1, 2 and 3 just by putting the value of k equals to 3 into the given probabilities. And using the expression for the mean value, that is the x bar equals to summation of I equals to 1 to n xi pi, you will get the mean value of the random variable x here. So x bar equals to 3 by 10 into minus 3 plus 1 by 10 into minus 1 plus 2 by 10 into 2 plus 4 by 10 into 5, and simplifying this, here expected value or the mean value of the random variable is equals to 1.4. Let us consider another example. A random variable x has the following values. X has the values 2, 4, 6, 8 and the probabilities are given. For 2 it's 0.1, for 4 0.2, for 6 0.3 and for 8 it's 0.4. Calculate mean. Number 2 mean square value, number 3 variance and number 4 standard deviation. So here mean value can be obtained by using the expression for the mean value, that is equals to summation of I equals to 1 to n xi into pxi. So here x bar equals to 2 into minus 0.1 plus 4 into 0.2 plus 6 into 0.3 plus 8 into 0.4. So this gives mean value equals to 6. To find out the mean square value, that is x square bar or expected value of x square, this can be obtained by summation I equals to 1 to n xi square into pxi. So here 2 square into 0.1 plus 4 square into 0.2 plus 6 square into 0.3 plus 8 square into 0.4, and simplifying this you will get the mean square value, that is equals to 40 here. Now you know the variance, that is equals to the mean square value minus the square of the mean value. So here the mean square value is 40 and the square of the mean value is 6 square, that is 36. So 40 minus 36 equals to 4, which is the sigma x square, that is the variance, and the standard deviation is the square root of the variance. So square root of 4 here is 2, therefore the standard deviation is 2. Now let us take another example. If x is random variable which has a PDF given by fx of x equals to x by 2 for x lies between 0 to 2 and 0 otherwise, calculate mean and variance. So to find out the mean value, that is the expected value of x equals to x bar using the expression, that is integrating the x into the PDF over the interval minus infinity to infinity. So here the limit for the x is 0 to 2, therefore integrating x into PDF is x by 2 dx over the interval 0 to 2, and simplifying this integration, here you will get the expected value of x, which is the mean value, is equals to 4 by 3. Then find out the mean square value, that is the expected value of the x square, using the equation, that is integrating the x square into PDF over the interval minus infinity to infinity. Here the limit for the x is 0 to 2, so integrating x square into the PDF, which is the x by 2 dx over the interval 0 to 2, and simplifying this thing you will get 1 by 8 into 16, and that is equals to 2. And we know that the variance is equals to the mean square value minus square of the mean. So here the mean square value is the 2 and the mean value is 4 by 3. So take the square of 4 by 3. So that is 2 minus 4 by 3 square, that gives 2 by 9. And the standard, we can find out the standard deviation also by taking the root of the variance, and this is equals to root 2 by 3. Let's take the another example. For a given random variable x whose PDF is shown in figure, calculate variance sigma x square. So here the PDF is given. So first find out the expression for the PDF for the x lies between 0 and 4. So comparing this given figure with the standard PDF as shown in the right side, the expression for such PDF is x minus a by b minus a for x lies between a and b. So from the given figure, here b is equals to 4 and value of a is 0. Therefore the PDF is equals to put the values of a and b into the equation that is x minus a divided by b minus a, and for x lies between 0 to 2. So therefore we obtain the PDF here, fx of x equals to k, which is the magnitude, x minus a is 0, therefore x minus 0 divided by b minus a, here b is 4 and a is 0. So from this we can obtain the PDF, which is equals to k by 4 into x. Again, the area under the PDF is always equals to 1. So from this we can find out the value of k here. So integrating the PDF over the interval 0 to 4 and equating this thing equals to 1, and simplifying this thing you get 2k equals to 1. Therefore the value of k is equals to 1 by 2. To find out the variance, we have to first find out the mean square value and then the square of the mean. So let us first find out the mean value of the given PDF. So integrating this PDF over the interval 0 to 4, x into the given PDF is k by 4 into x dx. So this equals to integrating from 0 to 4, k by 4 x square dx. K by 4 is constant, so take the outside of the integration and then integrate the x square over the interval 0 to 4. We will get k by 4 into 64 by 3, and simplifying this we will get mean value equals to 8 by 3. Now let us find out the mean square value of the given PDF. So mean square value of the given PDF is obtained by integrating from 0 to 4 x square into the PDF k by 4 into dx, k by 4 x into dx, and that is equals to k by 4 integrating from 0 to 4 x cube by x cube into dx, and simplifying this you will get, putting the value of k is equals to 1 by 2, we will get the mean square value of x, that is equals to 8. Therefore the variance is equals to the mean square value minus square of the mean value. So mean square value here is 8 and the mean value is 8 by 3, and taking the square of that thing will be 64 by 9. So 8 minus 64 by 9, simplifying this thing you will get the variance equals to 8 by 9. Let us take another example. What is mean and variance of a random variable x whose PDF is shown in figure? Okay, now from the given figure it is clear that this is the uniform distribution function, uniform distribution function, and the PDF for the uniform distribution function for x lies between a to b is given by 1 by b minus a. So here value of b is 3 and value of a is minus 1. Therefore, the PDF for the given figure is equals to 1 by b is 3 minus a is minus 1, and the height here is k. So this is equals to 1 by 4 and that is equals to k. So using this PDF we can find out the value of mean as well as the mean square value. So to find out the value of mean, expected value of x equals to x bar equals to integrating from minus infinity to infinity x into PDF. So the PDF is 1 by 4 and put the value of the PDF which is 1 by 4 and integrating over the interval